Chapter 9, Lesson 1, Date being 319, and you have two vocabulary words, bivariate data, which is data with two variables, and scatter plot, which is the relationship between bivariate data graphed as ordered pairs. And you can see here you have different relationships or associations. This is a positive association or relationship because you can see that as the x values are increasing, the y values are increasing. A negative association is where your x values are increasing, but your y values are decreasing, so it's going downhill. No association is when the information is just scattered on the graph. There's no obvious pattern. And if we have a linear association, we're looking for that straight line, or they lie close to being a straight line. And for a nonlinear, we're talking about the points are in the shape of a curve. You can have outliers, and you can have a cluster of information. So example number 1 says, interpret the scatter plot of the data for the amount of memory in an MP3 player and the cost based on the shape of the distribution. So we are looking for the variable association. So we are looking for, is this a positive, a negative, or is there no obvious pattern? And to me, it looks like there is a positive association. The memory increases as the cost increases. The linear association is that this is linear, it's not nonlinear. The information is very close to a straight line, and there is a bit of a cluster, and that is around 1 to 2 gigs. So this kind of area in here. So there's a cluster at 1 to 2 gigabytes, but there is no outlier. And so there we've interpreted all 3 different things for the scatter plot. We're ready to move on to number 2. It says interpret the scatter plots. We're going to do the same thing. We're going to find A, B, and C in the same way. So this is the 2 weeks in May, the amount of ice cream sold at a shop based on the shape of the distribution. And so does it have any association? It does not look like there's an obvious pattern, so there is no association. And it is not linear, and it is not nonlinear, so it's neither. No pattern looking like a straight line, and there's no curve. So these both are no. And looking at the information, there is no cluster that I can see, and there does not look like any outliers. So everything is no for this. Okay, moving on to the next page. Now we're actually constructing a scatter plot. So it says construct on the weight of an alligator at various times after hatching. And so here's our X, and that is the amount of meat. And here's our Y, which is the weight in pounds. and 15, 43 and 17.2, and 49 and 19.8. And so you can see that it looks linear. It's in the shape of a straight line. But all they asked us to do for this one was construct it. So there's your scatter plot for number 3. For number 4, we have the table shows the average extra fuel used by drivers in one city due to travel delays in congested areas. Construct and interpret. So we are going to interpret in this scatter plot the data. If an association exists, make a conjecture about the excess fuel that will be used by an average driver, and we're looking for 2020. So this is the year since 1980, it says on the graph. And so 2020, that was 30 years ago, or 30 years after 1980. So that's what we're looking for to kind of base it on what fuel in gallons they would use. So let's construct first. We're going 10 and 31, 15 and 24, 2020, 25 and 17, 30 and 10. And so it looks linear. It also looks negative association. And there are no clusters and there are no outliers. And so here's the best way to determine where we would be at 2020 is to draw this line that we're going to get in more to in the next set of notes. But you notice that, okay, 2020 is 40 years after 1980. So we're looking for, where are we here? Well, if this line continued, it would end up right here at 0 gallons of excess fuel in 2020, because that's 40 years after 1980. Question number 5 says the table shows public school in the number of units produced by a certain number of hours at a manufacturing plant. Construct and interpret the scatter plot of the data, and if the association exists, find the production in 50 hours. So we have time for our x-axis, and we have units produced for our y-axis. We have 8 and 20, 19 and 41, 16 and 28, 40 and 60, 34 and 49, 8 and 28, 40 and 63, 19 and 40, and 34 and 58. And so our association looks positive. The information is headed in a trend of a positive slope line. And it is in the shape of a line, so it is linear. And we're looking for 50 hours, which is way over here. So I'm going to just place that line through the data as best I can. And at 50 hours, I am right about there, which is, I don't know, somewhere about 75 units produced. Right in the middle of the 70 to 80. So this is Chapter 9, Lesson 1, Scatter Plots. Bring these notes with you to class tomorrow with your book pages, and we will do some examples. Have a good night.